Now keep going for the graph of cosine. Now, if we try to think about sine function and the cosine function, basically are the cofunctions. So means the whole graph will be different by pi over 2, 90 degrees. So in other words, the value for the sine function on the pi over 2 should be the value on the same value for this, for the cosine, because they are cofunction. Okay, so the cofunction, cosine function, let me use this color. Let's try to graph y equal to cosine x first. Y equal to cosine x looks like this. Here. And keep going, and we go down. Okay, keep going. Looks like that. There's a one period. Pi to negative pi, total 2 pi. So the period is supposed to be 2 pi. And if we multiply 3, then we don't have enough space. So let me change the graph to, how comes negative 3? Okay. So here we have 3 here. Okay. So I mean, if this is 1, okay, so the cosine function, parent function, this is 1 and negative 1. So this is cosine function. Now, if we multiply 3, then we have the y value need to multiply 3. So 1 times 3, negative 1 times 3. So you have negative 3. So here you have negative 3, negative 3. So, and the 0 times 3 is still 0, no change. So you have this graph. You have this graph. So my graph doesn't look very nice. Let me adjust a little bit. Okay, one more time. Okay, fine. So this is one period for the cosine function, 3 cosine. And if 1 times, then you have the green color. Okay, and you may have more angles here. 3 pi over 2, 2 pi. So you have 3 pi over 2, and it goes to 2 pi. Keep going. Same thing here. Negative 3 pi over 2, and it goes to negative 2 pi. So you can go up and up here. Okay. Keep going. Okay. So the amplitude is 3. This number. That's pretty easy because everything times 3. So the biggest number is 3. Now the period, because we didn't stretch or squeeze the graph, like earlier, we say we squeeze the graph, right? The original graph is kind of stretch up, and when you times 2, you can work these hours to earn the same amount. So you kind of the whole graph will be squeezed. But this just one times. Your boss is not going to pay double for you. So your period will be the same thing, 2 pi. Okay? Now, next example is here. Your boss is, this time you don't have a very good boss, very nice boss. Your boss is going to half of your work hour. Say if you work 2 hours, he count as you only work for 1 hour. Okay, so you need to work double hour. So that's why when this time your amplitude is still 3, no change, right? Still 3, negative 3. Okay, but the parent period is 2 pi, but your boss is going to divide by 2 for you. So follow the formula. You have 2 pi and times 2 over 1, right? Right, times 2. So you need to work double. You need to work 2 times harder. You need to work 2 times hard in order to earn the same amount, right? Okay. So in order to earn the same amount, you need to work double. So for example, this is 0 degree or radian is 0, so you didn't do anything. But in order to earn the same graph, you need to work double. So this one goes to here. This one goes to here. Okay. And here, the pi become 2 pi. So when it's 2 pi, then you have this one. Make sense? Okay, goes to here. So let me erase this mark. It won't confuse too much. Okay. So actually your graph should look like this. Stretch. So you work out more. You need to work more out. So like a stretch your work out. So we say stretch. The graph will be stretched. So this one goes to here. And this one will goes to there. Okay? So the graph stretched. So if you have half x, then your period times 2 become 4 pi. And you should just memorize the formula, easier this way. But before you memorize the formula, I explain so detailed for you to understand. Make sure you agree with the formula. So if you have divide by 2, you times 2. Oh, yeah, divide by 2, you times 2. Or you times 1/2, then you divide by 1/2. So this is the cosine. And then here, when we talk about stretch, this shrink, or I say squeeze the graph. And this type we say is stretch the graph. And keep going, we are going to talk about how about we want to shift. So the whole graph maybe shift to the other location. Then it's even harder, right? Keep going. When you have plus D, it means the whole graph push up or down, push up, down. The graph push up, down. This not too hard, but the hardest part is when your x minus c, what happened? So when x minus c means you want to shift to left or right. Shift to left or right. But how many steps? Not c. C is for bx. You shift left or right c steps for bx. But you need to say bx. Whenever you have bx, you shift for c. But for 1x, you need to shift for c over b. So this is a shift for 1x. So the real number we want to talk about shift left right is for 1x. Okay, so horizontal, the formula will be c over b here. That's a horizontal shifting. Formula is c over b. Because whenever we are going to talk about a shifting, we are talking about how many shifting for 1x, not for bx. Okay, so every 1x we shift for c over b. That's the formula. And the vertical shifting is just plus or minus, with depends on d is positive or negative. So far, okay? Okay. Now, so let's talk about. I will dip the graph for you by yourself for this one. No, probably too hard. Let me see. Okay, let me try. This is a sine function. No matter what's inside the input, sine function, the period will be always 2 pi. Sorry, 2 pi. No doubt. And this 1 multiplies sine. So the amplitude for sine is always 1. That's no change. Okay. And the horizontal shifted. This is for 1x. So you say x equal to pi over 4. Then that's the shifted pi over 4. Not the negative pi over 4, it's positive pi over 4. We learned that long time ago, right? And right now I want to make it become formula easier for you. And the horizontal shifting, there's a plus 0, nothing plus, so 0. If on the test I don't ask you to graph, only ask you to answer those questions, it's pretty easy as long as you memorize formula. Let's try next one. Okay. That's 1 times, so the amplitude is 1. And the period will be 2 pi divided by 2, which is pi. So this is B, this is A, and this is C. And the horizontal will be pi over 3 divided by B. So it's pi over 6. There's a horizontal shifting. You shift the whole graph right hand side for this angle. And the vertical asymptote, there's nothing plus, so it's 0. So same thing, if you agree with the formula, and memorize the formula, then those questions will be pretty easy. Next, the amplitude A is 3. Period, that's 1x. 1x, so you have 2 pi divided by 1 is still 2 pi. And the horizontal, x plus pi over 2, if you make it equal to 0, so you solve for 1x, shift for negative pi over 2. So this negative pi over 2 means you shift pi over 2 on the numerical line to left hand side. Shift. Vertical, because plus 1, this is D. So it's 1. You move the whole graph up 1 steps. Okay. And in the end, last one, amplitude is 3, and the period is 2 pi divided by 1/2, means 2 pi times 2, which is 4 pi. Okay, and the horizontal, you make this one equal to 0. 1/2 x minus pi over 8 is 0. So 1/2 x is 1/2 x move for pi over 8. And if 1/2 x move for pi over 8, let me make it better writing. You times 2 on both sides. So 1x you move for pi over 4. So this is pi over 4 shift. And the vertical shifting is -1 because the whole graph has been pushed down 1 steps. The whole graph. Okay. So this is the okay. So let me see. So should I graph for you? Let me erase that and I try to quickly graph according to the data. Okay, let me erase. Let me see. So we try to learn, once we understand the formula, how we use those data and quickly graph. Now amplitude is 1. So the biggest number is 1 and the -1. And the period is 2 pi. So let's say we say 2 pi. And -2 pi, how about that? And this is negative pi. This is pi. Horizontal shifting. So this graph supposed start from pi over 4. Pi over 4. If the graph starts from pi over 4, because 0 shift to pi over 4, right? So you can think about the parent's graph. Looks like that. And right now the whole thing shift to pi over 4. So everything shift to pi over 4. So pi become, so let me show you the parent's graph. The parent's graph should be like this way. This is our parent's graph. And then right now everything shift to pi over 4. So pi over 4 here, right? This one to here, this one to there, this one to there. So your really graph will parallelly shift. Make sense here? Okay, let me do one more time, okay? One more time. So parallel, okay, parallel. Yes, see, everything shift. all you have to do, your job is you have to mark the important number. Like this pi plus pi over 4, you have to calculate for me. This 2 pi plus pi over 4. All the important number, you need to plus pi over 4 for me. So that's your extra credit. Okay? So the graph will keep going. Keep going. Okay? I will let you finish. Now, what happened here? If you times 2, you have to squeeze, right? Because your boss pay double for you. So you have this one, the squeeze one. But compared to this one, it need to be shift to pi over 6. Okay? So the graph here shift to pi over 6. Let me talk about the graph here for you. Shift to pi over 6. So every number shift pi over 6. So everything pi over 6. Understand? Sorry, not go through there. Pi over 6. Pi over 6. I roughly do it for you. Okay, but you have to go home try by yourself. Okay, something like that. Okay, now so all the number here, you have to 3 pi plus pi over 6 to be here, right? Every important number, when you shift, this number become 5 pi over 2 plus pi over 6. So this also your extra credit job. You have to do it by yourself. I just do 1 or 2 for you, and this is a graph referred to this one. Okay, so C y equal to sine 2x. So this is the graph you have to finish by yourself. Now for the cosine, if you multiply 3, so we say this is 3 and the negative 3. And the graph, cosine graph should look like that. Okay, you can go back to check. Now, plus pi over 2 means you need to shift everything to left hand side. So if we shift everything to left hand side, negative pi over 2. Negative pi over 2 actually is here. So whole graph shift become here. Okay, we shift. And this one shift pi over 2 become there. So same thing parallel, you shift. You shift your graph pi over 2. So the important number you have to change, right? Now after shift, you push the whole graph plus 1. The whole graph plus 1. Let me choose a new color. Everything plus 1. Plus 1. So this becomes 4. Right? Everything plus 1. Everything plus 1. So the new graph, let me change it to other color, any better color. Black. Okay. So the whole graph push up. So this graph being pushed up. This graph being pushed up. Okay, so this graph being pushed up this way. So whole thing push up, push up, push up, push up, push up, push up. And for the detail on the numerical 9, the number here, what's the angle here? That's your job for your extra credit. Now, this one, half. Half means you stretch to double. When you stretch to double, this graph will be kind of like become flatter, right? Here, you stretch up. This one become here, and this one become there. Everything double, so it's like this. Okay, this one. Okay, and then you push down one step. Same thing, this question I will let you finish by yourself. It's extra credit. I will let you try. Sorry, I make so many marks here. This one I should erase because there's nothing to do with this question. Okay, so that's it. And this one I will let you try by yourself. And if you have a question, you can ask me in the class time. So see you next time. Bye bye.